afternoon, everyone. It's a great honor to be here today to celebrate the extraordinary Carleton career of Professor Julie Neiworth. Julie has spent the past 38 years inspiring Carleton students through her outstanding dedication to teaching, research, and mentorship. I'm Dr. Kathy Lawrence Charlo, class of 1989, and I do think the last time I was in this room, I was taking a bio final in the spring of '89. Looks about the same. Julie's first term at Carleton that fall was my senior year here, and through great luck and good fortune, I was Julie's first comp student. To put the 1988-89 academic year, Julie's first, into perspective, landlines were just added to dorm rooms around that time, instead of one shared dorm hallway phone that we never answered anyway. And we were literally just figuring out how to use answering machines, and I don't recall Julie's office having one yet. Among my most memorable senior year experiences are all of the Sundays spent with Julie fanning out the pages of my comps on her office floor for feedback and guidance. No email existed yet to upload the many drafts of the developmental study of children's friendships Julie taught me how to complete. Some of us who were her first students, and Julie herself, now have adult kids of our own who are at the same stage of life as Julie was when she began here at Carleton. But knowing her then, her confidence and expertise, we recognized that she was already prepared to continue her totally relentless intellectual journey, the foundation for her outstanding career here at Carleton. Julie's contributions to the field of comparative psychology are remarkable and could not possibly be summarized in the few minutes I have up here, unless I make a reprise of my own 1989 comps talk, where my rate of speech accelerated so much. A 10-minute presentation took only 2. Do you remember that? Do you remember?
What's going to mention it?
True. Julie's prolific work with primates has greatly added to our understanding of memory, cognitive flexibility, development, social awareness, and even the roots of fairness. Through the Neiworth Primate Lab here at Carleton, a major and ambitious achievement, Julie pioneered a natural aging model that is critical to our understanding of cognitive decline. But if you ask her colleagues or her many students, they will likely tell you that her greatest achievement isn't a paper in Nature or the Journal of Comparative Psychology, though she has many. It is her mentorship. Look at any of her outstanding publications, and you will note a sea of asterisks next to the names of co-authors. Each of those represents a Carleton student. Mention news of any past student who took one of Julie's courses, or worked in her labs, or was advised by her, and she remembers them, whether you refer to someone from the class of '89 or a most recent grad. Julie remembers you, has followed your career, and she is often a primary reason we return to campus year after year, to share career updates or consult about current research with her. Those who have opportunity because of Julie's dedication to the Carleton experience, and those who have become impressive researchers and educators, clinical psychologists, healthcare providers, and nonprofit leaders, directors of major graduate programs, or combinations of so many professional possibilities. What we all have in common is sharing the experience of Julie's unwavering commitment to our learning, to ensuring our critical thinking, to showing us again and again how to engage in an ethical culture of scholarship and research, and how to see limitless possibilities, because Julie was there with us or sitting on her office floor with us. And above all, she saw opportunities here at Carleton as limitless. Whether Julie was leading the psychology department, directing the neuroscience program, or holding office hours with students in her courses, Julie has been a completely dedicated presence. Still to this day, running back to campus to meet with students on a Sunday. We literally were at the Oldie store, and she had to cut it short. She had to come back on a Sunday. It's awesome. She showed us that learning at Carleton requires curiosity, empathy for other species, and a deep commitment to understanding the human and non-human condition. Julie, I did not expect you to be standing right there, so I'm gonna have to turn toward you now. Julie, for every student who found their career path through your dedication, and there are so many who will tell you, oh, I worked with the pigeons, or I worked with the monkeys, I worked in her lab. For every comps project you guided to the finish, and for making Carleton a place where we study by fully engaging, we collectively cannot thank you enough for the experiences you provided us at Carleton. Julie, thank you for being the person who reminds us that humans are just great primates with slightly better Wi-Fi for their iPads. Thank you for the decades of brilliant research and teaching, for the many rich experiences you brought to this tundra we all adore, and for letting the monkeys often have the last word. Let's give a warm round of applause to celebrate the distinguished career of Dr. Julie Neiworth. Okay, is this working yet? Yes.
Hi, thank you for coming, you guys. I want to thank Kathy for such a great introduction. I hope my talk lives up to all of these qualities that were described about me. I have to share a little story about Kathy. Neil Lutsky would give out prizes to seniors when they were graduating during our spring picnic every year back in the day when Kathy was there. And he crafted a prize for Kathy that was a jar of pennies. So he tried to appreciate their accomplishments and also have a kind of personal quality around it. So he gave Kathy a jar of pennies. He said, you know, my office is right next to you, and I just put a penny in this jar every time Kathy came in to ask you a question. That's what it was. I just want you to know, Kathy, I loved every second of our meetings. They were very useful, and it was very nice to do it. I enjoyed every minute of it. And with all of the work that Kathy did to make this event happen, and all the questions that I asked, I think I'd get a double jar of pennies from you. So thank you. And thank you all for showing up. And for those of you on Zoom, thank you for coming to hear my wrap-up talk. The work that I'm going to describe could not have been completed without a lot of help. They're great students. They're all great students for showing up, right? And great collaborators, and great colleagues, great stewards of the college that I counted on for the work. And this to me was a great place to do work and to teach. So let's get started. Because we're starting late, I'm going to talk faster. Not as fast as you, Kathy. So my title is a little peculiar, right? What it's like to be human. I do know what it's like to be human, so I want to clarify that right away. But really what follows from that question is what makes us unique? It might be obvious that question as well. Look around. I have 3 microphones up here. There's people para-visiting through Zoom, right? Everything's projected. You're sitting in seats that were designed for this room, and I'm trying to teach you in ways that humans teach, right? And it's clear that all those facets of human life are not shared with other species. So the output, at least from us, is unique. The comparative psychologists always dig deeper. We observe and then we pose problems to other animal species to see how they react, to get a glimpse of their psychological world. This includes them figuring out space and objects in their physical environment, and also whether they consider other animals, their others in their group, when they're thinking. Are we different from other species? What do we share in terms of cognitive abilities, choices, and considerations? I'm going to show you what I've learned in 38 years of working here and doing research, and also a postdoc, and also graduate school, and a little bit undergraduate school, so that I can sum it all up. And I was 26 when I got here, so just so you know. That's why Kathy mentioned that we now have kids our age when we at this stage. Okay, so I have to do a little bit of a very short origin story first. I hope you don't mind. Oh, no. No, it's not. There, good, it worked. So the first serious question I asked was when I was an undergraduate, a senior undergraduate at Reed College, and I started reading this book in 1982. That's when I started, I was a senior then, graduating, called The Image in Mind by Steve Coslin. It's brand new, just came out. You make mental images, right? So if I said red cube, you can imagine that. If I said don't think of a polar bear, now you're thinking of a polar bear. And so sometimes you can't really control it, but there's a visual quality about it if you think about those things, yeah? Steve Coslin wanted to figure out if your image that you make in your mind actually represents the real world. That is distance represented? Is size represented? Things like that. So that the idea is the image is just like something that you would see, except for you're creating it. So he would show people a map, for example, and then take it away. So they had to use memory of the map. And he would have them start in a certain place in X, and then he would have them wander around this map that they're thinking about and go to different artifacts that were drawn on the map. And he would say, when you get there, tell me, and he would time that. So if it was far across the island that was on the map, there would be a longer reaction time before he would say, or the subject would say, yes, I'm there. If it was close, then it was a shorter reaction time. So he claimed that that was evidence that the image that was created had these physical qualities represented in it. And of course, there were criticisms of that. So the major question was, what did you tell them you were studying? Because people may be affected by experimental bias, and then they might just delay a little bit if it's farther, right? And then say, yes, I'm there, or something. If they thought, oh, it's longer, I should wait, right? And so it was unclear that that was really solid evidence. But the people in my field, in animal cognition, were going crazy about this idea because they thought, well, most animals don't have language, or back then, at least they don't have language like ours, and they're not representing things in words. Oh, I can't walk that far because the chat people can't hear me. They don't have words or the structure of language that we often use to memorize things or something like that. So all they'd have left is images to use to remember things. And everyone was like, yeah, that sounds right, okay. And as a senior undergraduate, I'm like, what are you people doing? Are we building what we know about animals from vibes and persuasive arguments? Is that what we're doing now? And so I wanted to actually test something to see if they actually used images, and I was studying pigeons at the time. So now we're in graduate school with me, you're coming with me, and I started rotating clock hands in front of pigeons. This was my study that ended up being my dissertation. So you can imagine a clock that has hands like this, okay, not the digital stuff, right? And so it starts at 12 and it rotates in a constant speed to 4 o'clock or 6 o'clock. And the pigeons would be watching this, and they could peck a key with that constant rotation and get food, right? Sometimes I would have the clock hand disappear at 3 o'clock, and then nothing would be happening, there'd be a delay, and then it would show up either at 4 o'clock or 6 o'clock. If that delay was the correct time that it would take it to continue rotating to that location, then they should respond on that key. That means that's good, right? And I also had delays that were inappropriate. They were either too long or too short for the final location. And they had another key that they could peck on when it was wrong, and they would get food for saying it was wrong, okay? So it took several weeks for pigeons to learn this, but they could have been just memorizing. Goes to 3 o'clock, I wait 2 seconds, and I peck over here. Goes to 3 o'clock, and it waits. It's gone for 4 seconds, I go here, right? So they could have memorized something that has nothing to do with imagery, has to do with watching something move and then waiting a period of time. And the period of time doesn't match the location. That may be why it took them a couple weeks to figure out all the times and all the locations and be able to do it. So then I suddenly moved it to 5 o'clock. So they'd never seen anything move and stop at 5 o'clock before. It went through 5 o'clock, but didn't stop there. And I also made the hand disappear at 3 and show up at 5 correctly or incorrectly with the delays for 4 or 6, right? And the data showed immediately the 158 degrees. It's published, so I had to use degree measures instead of 4 o'clock, 5 o'clock, and 6 o'clock for you. But they could do it right away, so they're at 80 to 90% correct immediately. Then in a second experiment, I decided to change the speed of the hand that they were watching. So all of a sudden it was double time, really fast, or it was really slow. And I didn't train them that either, I just tested it. And it would show up where it should be, given it was moving at that speed, or it would show up incorrectly because the delay was wrong. And they got those right as well. So that meant that they were doing some work with the clock hand to estimate or extrapolate where it would be across those movements. And that is the publication you see at the top. It was based upon that work. Oh, also, people use that methodology all the time, I should just mention. So this is a 2019 article that was just published that has the imagery stuff that they're using. This is 2024, and there's somebody testing monkeys right now at Emory with that methodology, so people love it, so that's good, right? It was based on that study that I got my job at Carleton, and Peter Guthrie was chair at the time. He was a learning theorist too, and he was, I was meant to replace him. So awkward, right? Hi. He was very friendly, very supportive, a great guy for me to train under. I also worked a lot with Neil at that time. What inspired me right away was he really tried to encourage students to be independent thinkers, and he inspired them to do independent research a lot. And one of the stories he used to tell me, this happened like 10, 15 years before I got there, but Carleton students used to hop empty railway cars and just for fun and ride somewhere. They get ideas for this every once in like a couple every year did this. Not the same ones, just randomly they get this idea or hear about it. And what happened is then they didn't want to jump off when it was running, because that's scary. So they would just wait for it to stop and get off, and then they'd call Peter. And he said, usually I went to Red Wing, sometimes Stillwater, to pick them up. He always went to pick them up and drive them back. And he said, Peter, what? What did you say? He said, well, I didn't want to punish them. They're trying to do something new. They're being creative. They're reaching out. And so, you know, they never did it again. It's an awful experiment, right? So he was a great guy. Since I got here, I taught learning and memory for almost every year, and always with pigeons, up to 2 years ago. So the picture that I just put up with the pigeon looking at the monitor, those monitors are what we were using the last 10 years or so of teaching. And I always had students do planned experiments with me that I had constructed, especially to train up the birds so that they would be responding for food and looking at the screen and thinking about visual stuff. And then I said, you've got to make up an experiment yourself now. And they always had to do a poster as well. And this one is, I think C's in the audience. Oh, hello, it's Laredo. His pigeon, whose name I'm not going to say. Okay.
You want me to say it?
You can say it.
Schrödinger's pecker.
Yeah. So that pigeon, as I refer to it, learned to respond to a baby mudkip from Pokemon, if you can see that. The beginning of mudkip. And then the test was to try evolved successors to mudkip, because they share some traits, to see if the pigeon thought, well, that's close enough, or that looks like the same guy. And the bird did peck to some of the evolved successors, so that's always fun. When I got here in 1988, the courses were listed in a book, and you couldn't look at them online, and that was the first catalog in my first year. And this was a description of the psychology department. And here is me with my flock of seagulls haircut. You can Google that later, it's a band. And this is Kathy Galati. And this is Larry Chinsky, Neil, yes, and Sharon. These are all Sharon Akamoto, babies. baby faculty. And this is Steve Cosberg, who was also here then. So that's the motley crew I came into. All right, we're going to fast forward now to 10 years later, 1998. And I was given 8 monkeys. They were top tamarins. They are top tamarins, which are New World monkeys. And Chuck Snowden from University of Wisconsin-Madison was visiting and toured the animal facility and said, hey, you could have monkeys here. Now, I had worked with rhesus and cacs when I was a postdoc, which are very large. If you watch Punch, those videos, those are Japanese macaques. They're very closely related. So that's what I was dealing with. And so I knew about monkeys and I knew what they needed and how to deal with them. These guys are very small. You can see squirrel size. The Carltonian, I was surprised. The Carltonian did a story in January. We got them in December of 1998. January 1999, I was front page of the Carltonian. I was surprised to read that we had received 17 monkeys for education and research purposes. I was like, really? So that was my beginning of relationships with the press. And that's a picture of me sitting on a couch with my child, Izzy, who was 3 when I got the monkeys. And we were waiting for the vets to look them over. And this is Izzy now. They are 30, so you know how long I had the monkeys then. Well, everything starts with a book with me, Image and Mind, by Steve Coslin for my PhD. And in 1997, the year before I got the monkeys, Primate Cognition came out by Tomasello and Call. It's sort of our Bible. It's a great review. I'm reading it right now with Ostap Revenue. Did it. And we're going to zoos and things to do some behavioral coding. There's a chapter at the end of this book that describes a theory of primate cognition. And the idea is to try to look at all the species across the tree of primates and keep track of how they evolved and also what they have now in terms of their thinking, and try to make sense of what are shared qualities across them and what are distinctly unique. And you can see at the top of that kind of branching tree, marmosets and tamarins. They're in the New World monkey category. And then there's Old World monkeys, apes, and lemurs. What Tomasello and Call were recommending, they said, you know, they built this theory, but it's severely lacking in any data about New World monkeys and about lemurs. And most of it is based upon Old World monkeys and apes. And if you know about evolution, so Old World monkeys branched off a common ancestral tree of like 25 to 30 million years ago, and apes branched off 10 million years ago. Humans went through their iterations like 6 to 7 million years ago. So they're the more recently evolved monkeys on this, and apes on this primate display. So New World monkeys, tamarins and marmosets and the rest, branched off 45 million years ago, and prosimians, which are lemurs, that means before simians, were 55 million years ago from mammals, yeah? So the older evolved animals, primates, most people didn't know much about. So that was my impetus to try to study those and try to fill in the gaps and understand how they were thinking. So the other thing, I forgot to mention this, the other thing that Tomasello and Call said was you have to look at physical cognition, what the animal thinks about in the real world, their physical space and the objects and things like that, how they problem solve, and also their social thinking. So how do they think about themselves, or do they think about themselves? Do they think about others, and what do they, how are they affected by making those considerations? So I'm going to start with physical cognition and talk a little bit about what we did with that. What I did, in addition to having the one of the primates in the group that was missing from the Tomasello and Call book, was to select cognitive tasks for which humans often show special properties. So if I picked that and the monkeys had it, then it would definitely be shared and interesting to find out. Also, some of the tasks that I use, some of the topics I'll go over today, develop in humans so that younger versions of humans, like 3-year-olds or 4-year-olds, can't do it, and then later we are able to do it. So it's possible that another species of primate would be stuck at a beginning level or look more like a younger human in terms of their ability to think as opposed to an adult. So you'll see me testing toddlers a lot and college students to compare with the tamarins so that I would use the same task across them all. One of the things that we're pretty unique about, we thought, was face processing. So when you look at a face, you look at the eyes, nose, and mouth, and you look at it holistically, like it's a group. The reason we know this is if the face is inverted, it's presented upside down, it's harder for you to tell who it is. You take a much longer time, and sometimes it's really hard to tell. You can tell right side up, and if I change the face, it's a different face, right away you know it's somebody else's face, not the same face as the first one. But when they're upside down, it's harder. You take longer to compare them because you can't use that holistic processor. So I decided to use that kind of task with tamarins in college students. I used tamarin faces, which are the first ones, the human, I hope you can recognize that, and chimpanzee faces. Chimpanzee faces wouldn't be familiar to humans or to tamarins, right? They didn't run into chimpanzees very often. And also office objects like staplers and tape dispensers and stuff like that. And we showed them both upright and inverted. In the case of college students, they were able to discriminate human faces just fine. They struggled when they were upside down, and they couldn't discriminate the tamarin faces right side up or upside down, nor the chimpanzee faces. Everyone did okay with objects, both species. So, just so you know, so I don't have to repeat that. In tamarins, the tamarin monkeys could discriminate between tamarin faces just fine. They couldn't discriminate between chimpanzees' faces very well. So it means like you think, well, that could be the same chimp, I don't know. Is that a different chimp? That's the feeling you have, and that it shows in the behavioral record that you're doing that. And they also had trouble when the faces were upside down. They had a little bit of trouble. They did a little worse when they were inverted, the tamarin faces. So it looks a lot like holistic face processing, the way that humans do it. The special superpower that the tamarins had is they did the same thing with human faces. They could discriminate between human faces, and they had a little bit of trouble when they were upside down. And it's probably because they have a lot of experience with human faces, but they would process us holistically as well, whereas we don't process them that way. So kind of interesting. And you can see authors coming up, and many of these people, I know Janice is in the audience right now, so you'll see that the students, all the authors after me are students who worked on the projects. Okay, now I'm going to show you some stimuli. I'm going to take them away for a second. So you saw the matrix that I'm going to put up here. And there are items that go 1, 2, 3, 4 from left to right, and one of them is different from the other ones. So I want you to say the number of the object that's different. Okay, can you do that? Okay. So we're going to start with the first, all 3 rows are going to show up. We're going to do the first row, then the second row, then the third row. Okay, you ready? You have to do work because it's me. I'm sorry if you thought you could just sit there. That's not happening. Okay. Which one? Good. Second row? 2. The third row? 1. Okay. I don't know if you found that difficult or not. What I'm going to show you next, I add a feature to every single picture. So it actually shouldn't make one object different than the other objects. In the first one, I'm going to add an L to every single one. The second one, I'm going to add a circle in the middle to every single one. The last one, I am going to organize the colors a little bit better for you, so you can see the difference. Is that faster for you? Yes. So that means that you use Gestalt principles, grouping principles, to recognize objects. If that took the same amount of time than the first one, then you don't, right? So we can see whether or not the monkeys we're using Gestalt principles by how long it takes. And I can tell you that we tested college students, we tested children with autism, they were high-functioning high school kids, toddlers who are between 3 and 5 and tamarins. And everybody thought the second group was easier than the first group. They took less time to do it. So they were all using those Gestalt principles, and it makes it pop out so you don't have to scan it and figure out which one is different. Now, I'm gonna tell you, if you can see those two figures, the top one is correct, and the bottom one is not correct, okay? Take a good look. Now they're gonna go away. Now I'm gonna show you two, and I just want you to say top or bottom, which one you think is correct, as quickly as you can after I show you, okay? You ready? Okay. So actually, that is right, but if we look back at the original, there's a shape that's a circle. That's the global shape. And it's made of little elements that are also circles. Do you see that? And the bottom one is a square, a shape, a global shaped square. And it's made of little squares. The little parts are called elements, right? And the big part is the global part, the global shape. What we do always is, as adults, is go with global shape. We show global preference. So if you were looking at the elements, the bottom one could be correct, because even though it's a square shape, it's made of circle elements. And the first one was also made of circle elements. So if you're paying attention to the elements, you might think that one's right. The top one is a circle, but it's made out of squares. That was bad before, okay? The elements of squares were bad before. So the question is, what would somebody pick? If they pick based on elements, they would pick the bottom one. If they pick based on global shape, they'd pick the top one, yeah? And what happens in humans is with babies or children around 1 to 2, they think both things are equally important. And with babies, we use look rates and habituation, dishabituation to see what they think is surprising, okay? And they treat the shape and the elements as equivalent. So they do that. By the time they're like 5 to 10, they start showing this preference for global shape, and they would pick the way that you do. And we found that in this one, you can see the title, we tested college students, 5-year-olds, and adult cotton top tamarins. They all did it correctly with this display, but then I started taking out the elements so that it was more sparsely drawn as a global shape. And when I did that, both the 5-year-olds and the tamarins thought both things were important. So I weakened the shape by taking out elements. So it shows that tamarins were more like 5-year-olds than adults, meaning that they were willing to use the elements as part of the problem. We looked at categories of animals. You might think, well, how would you learn that? Because we think of language when cats versus dogs. But what you do when you're a baby or you're a toddler is, that's a cat, that's a cat. You see a dog for the first time and you think, maybe that's a cat, I don't know. And someone goes, no, that's a dog. And so you learn how to group these things together from experience, right? So we showed monkeys golden lion tamarins, pictures of golden lion tamarins. And then we suddenly showed them a pygmy marmoset and they're like, nope, that's not what I saw before. When we showed them 4 species of monkeys mixed up over and over and over again, then all the monkeys were the same. New monkeys were monkeys. They were all boring. And to my disappointment, apes were monkeys. And I say that because y'all think chimpanzees are monkeys. I can't tell you how many times somebody goes, oh, that's such a cute monkey, and I'm just like, huge difference to me, okay. But apparently, it's a common finding across all primates, right? But even though they put apes in the monkey category, all the non-primate mammals, we showed them elephants, prairie dogs, squirrels, they were not monkeys. Apes were monkeys and monkeys were monkeys, but they were not monkeys. Okay. I have a few more physical cognition questions, and then we're going to go to social cognition. Okay. So one of the other questions I asked was about rule shifting. 3-year-old children if they learn a discrimination, the way they would learn it, you would show them 2 cards, and you'd say, one of them's correct, pick one. And in this scenario, like if there were the 2 boats at the top and you pick the blue boat, that would be correct. And then you get the other 2 cards, a boat and a truck, and the truck is blue, that would be correct. So they should learn it's blue, and then they would pick based upon that. So that's their first rule, it's blue. Then we change it, we don't tell them, and we change it, okay? If we change it to red, it's still color, so it's very, very easy. And 3-year-olds can do that. They can switch within a dimension. If suddenly the rules change to boat and color's irrelevant, just pick the boats. They can't switch. They keep perseverating with the first one. And this has been studied for a long time in a sorting task. And in that case, in developmental psychologists would tell the kid the rule. Now we're going to do the shape game. What would be correct in the shape game? And they pointed out, if you said boats go here and trucks go here in the shape game, but before they were doing blue and red, they point, okay, boats go there, trucks go there, here's a blue boat, blue. You know, they sort on the first rule. They can't keep both rules in mind when they're that little. They can do one, and they can do it in reverse. They can learn all the shapes, and then you suddenly switch to color, and shape is irrelevant. They crash and burn, okay? So we wanted to see, by 5, by the way, children can do this. They can keep both rules in their head. They can switch without any problems. So we tested that with children 3 to 5 and monkeys, and we found that the 5-year-olds could do it, could switch. The tamarins could also switch. They're adult tamarins. They could also switch, and the 3-year-olds couldn't. So that verified that the monkeys could use rules and switch rules and use different strategies like 5-year-olds to adults do. Then there were several tasks we used as they were aging. So this is monkeys getting older and older into extreme aging. And what happens to humans when that is going on? The 2 cognitive abilities that are compromised early on are attention and working memory, especially for new items. So people, as they age, they start having trouble with attending to the important things. What they do is attend to everything. So the distractors also try to code everything. And so if you flash things that aren't important on the screen, they do worse because they're paying attention to that as well. And also if you give an older person a list of words and you wait a bit and you test them, they won't remember as many as you do. They lose new information faster. If they have any sort of dementia, it's significantly faster. It's a square wave down, but even with regular aging, that happens. So we used a visual search task for attention. Again, it's a game where you have to pick the one that's odd. And in the first case, over to the left, the orange circles are different from all the orange stars. So that's the one you would touch. That's called a disjunctive trial. There's only one feature difference and it kind of pops out. It's an easy attentional task. The bottom one, over to the left there, is a conjunctive task. I don't know if you can tell which one. It takes a little work, but the bottom left quadrant has orange circles and green stars. And all the other ones have green circles and orange stars. Do you see it now? Okay. So that's harder, and as we age, that gets harder. Either it's very slow to find, or there could be incorrect responses to it. I'm looking for my mouse. So now I'll show you monkeys doing that.
Would you like to play a game? Yeah. Would you like to play? Which one? Which one? Yeah,
So I started them very easy.
Good job.
Big blocks.
Good job.
That's how
Want
we
to play
go.
again? Oh, which one?
Now
Which
this
one?
is like your disjunctive.
Yeah. That's
Now I counted
correct.
that correct. 4 fingers in the right place. They have a really hard time reaching when they get old. If it's less than that, we don't count.
That's correct.
Did you see that? So that's the conjunctive trial. So they can do it. They get a little, oops, they get a little worse with age, but they still do very well. Now I'm going to show you. Oh, I should wait and explain it. Sorry. Let's see if I can pause it. To study working memory in monkeys, you can't use a list of words, obviously. We use a task called match to sample. There's a sample that is up, that's an object that's in the center and the top. And then it goes away when you're trying to test memory for this. And then after some delay, 1 second, 10 seconds, or 30 seconds, 2 objects appear at the bottom. One of them matches the top one, but you don't have it in front of you anymore. You have to remember it to be able to do the match. The other one is just another object. So this is how you're best working on that.
Here, look, come down, look.
At first, we do perceptual matching, so they learn it. And I put a virtual Cheerio on you. I let them, they're cheating, totally, to get them to learn the task, right? So
Which one?
that looks like a Cheerio, that's what they're getting as a treat. This one is a memory task.
So come down, it's gonna happen any second now. Yeah, I know, hello. Look, look, look. Hold on, wait, which one, which one? Good job. You're so smart.
You do. What's up? Welcome to the
That, you're gonna see part of that later. It's not, but not now, sorry. And so we published an article where we had tested a lot of monkeys on those kinds of tasks to show that they do lose the ability over age. In this case, they really struggle with 30 seconds anyway, even younger monkeys do. That's a long time for them to wait to respond to something, but they do okay, but they don't do great. As they age, they start losing 10 seconds delay, so they can't remember after 10 seconds. They usually can do the 1 second. So we see a lot of memory failure as they age, just like we do in people. Okay, social. So we also were interested in what they thought of others and whether they could understand that others had knowledge or something to share. Right? That seems like a human unique ability. So this is a perspective taking task. You know that if you look at something, often other people will look in that direction. It's a social psych trick. It's everybody looks up, maybe look, ha, ha. I mean, they don't say that, but that, they're studying it, right? So what we did in this task is we put a big box over these 2 cups and then hide a Cheerio under one. We touch both the cups to make sure that we weren't signaling where we hit something. And then we take the box off and either just look at the cup that was correct or just glance, so your head is this way and your eyeballs go that way, or point and tap. The monkeys could follow looks very, very well if you used your head and your eyes, so you can see they're at like 75% correct. They couldn't follow glances, so it'd be at 50% if they were guessing, and they will guess when they don't know. They didn't love point and tapping, but we were pointing right at the cup and tapping, and I realized that seemed kind of competitive and aggressive to them, because some of them would go to the cup that we pointed to every time, and some of them would completely avoid the cup that we were touching and go to the other ones. They would be below 50%. They're like, nah, it's yours. Go ahead and take it. Okay, they're so into it. Go ahead. So that was interesting, but it seemed like they knew from our looking that there was something important there, and that's where they went. We did the same kind of procedure. You can see the box. This is Dee Dee Rupert showing a monkey a Cheerio. She has the box over 2 cups, and she will hide the Cheerio in one of the cups, but touch both of them. And then she leaves the cage. And either she comes back in and points to a cup with the box off, or Clint comes in, somebody who was not present when the hiding happened, and he points to a cup. And the question is, do you follow one over the other, or do you just guess? And what the monkeys do is they follow the knower. We call the first person the knower. They know where it is, and they would guess. In this case, you can see that Clint's pointing, and now we point really far away, so it looks goofy, because if you put your finger on the cup, they don't want it, right? But the monkeys would just as readily pick the other cup, the cup that Clint wasn't pointing to. So that's a kind of a theory of mind test. We also switched roles, so Clint was sometimes the guesser, and we used a lot of students doing this. And every time, they would go to the knower and just guess at the guesser. So you don't know what you're talking about, which means they kind of understood what each of us knew from the task, which was pretty remarkable. I'll show you a video in a second with monkeys looking in mirrors, but we tried mirrors. That was the first study we did when they came in. It was a couple days later, I'm shoving mirrors everywhere. So we're trying to see how they react to the reflection, and this is sort of a test of self-awareness. It's hard to ask a monkey if they have an awareness of self, but you can tell if you do a lot of behavioral coding, what do they do in front of the mirror? Do they habituate to the mirror? Do they use it in different ways? Caitlin, who's you're seeing there, she was the mom of one of the first groups I got. She was very interested in it. She would also stick her tongue out while she was looking in the mirror sometimes. And I was in there once, and she backed up and kind of sat sort of on the corner like this. And I looked in the mirror, and her entire body was in the mirror, and her head. So like, she's like, well, what do I look like when I do this? So it was really interesting to watch what they did with mirrors. I'm going to try to do some things quickly here, because I don't want to go over by too much. But there were some other tasks we used to try to investigate social thinking. One of them was social inequity. Franz de Waal, who was a famous primatologist who died last year, he wrote like 8 books. He studied chimpanzees a lot, but he also studied capuchin monkeys. And capuchins are one of the only New World monkeys that's studied a lot, and the ones I'm looking at haven't been. And what he would do is give them a pile of rocks, and they could come and trade a rock for a treat. Okay, so at first, and I hope you can see there are 2 monkeys there that are separated with a transparent wall, so they can see each other. And at first, he would trade a rock and give the one a grape, and then he'd go to the other one, trade a rock and give a grape, right? And keep that up for a while. Then all of a sudden, the first one gets a grape for the rock, and the second one gets a piece of celery. So, that's not good, right? And the question is, what would they do? So he keeps playing the game, but he's giving one grapes and the other one celery. The one that's getting celery starts throwing the rock back and throwing the celery back, and then refusing to play. Like, what's going on, right? So they're noticing their peer is getting something that's better than them, and they're not willing to keep going. I studied that with the tamarins, and we used Cheerios as the positive thing and grapes for the negative thing, because they love Cheerios much more than grapes. And long story short, so I tried, and they had little poker chips that they would give us for the treats. And I tried work inequity. So at one point, so food equity, they both got Cheerios. They didn't reject. The graph shows how much they're rejecting playing the game, either by throwing the poker chip at us or throwing the treat and then walking away, or climbing away, I should say. And when it was equitable, they didn't reject very much. When there was work inequity, so somebody had to eat 2 poker chips for their Cheerio versus 1, there was a little bit more rejection, but it wasn't significant. When it was food inequity, and somebody's getting grapes instead of Cheerios, there was significantly more rejections. And when it was food and work inequity, we got a lot of rejections. If we had a bowl of Cheerios there that we refused to give them because we'd only give them grapes, they wouldn't play either. But that's the food control condition. But that shows that they're kind of measuring what their peers are getting versus them, which is something you wouldn't expect out of monkeys, right? And we tried studying cooperation several ways. One of them uses this triangle that you see with the 2 rope. It's a single rope that's looped through the triangle. And we give them both ends of the rope through a little hole in the cage. You can see Wizard, that's Wizard doing it. And if she pulled it forward with the 2 ropes together, the triangle would slide forward and she could get treats out of it. So they knew how the apparatus worked. We trained them that much. But then all of a sudden we put the ends very far away from each other. So there was a great distance and they couldn't grab both of them. And we waited to see what would happen. And about 30% of the time, they would be able to pull together. One of them would get to a rope and kind of sit there and wait. If you just pulled one end of the rope and the other end was over there, you just pull it all the way through the triangle and nothing moves, right? So they would look at the other monkey, and so they kind of figured it out. It was a hard task for them to figure out. The other parts of the graph have to do with competition. We thought, if there's competition, will you cooperate faster or more? So we would show them other monkeys. There were curtains between the cages so that they wouldn't feel like they were threatened by other monkeys. They could hear them. If they couldn't see them, that was fine. If they could see them too, they'd go, hey, how about getting out of my tree? You know, and that would happen all day. So we had curtains, but we'd open the curtains. In one case, we put the rope on both sides. The rope went to one cage and another rope went to the second cage. And so they were actually, who's gonna get the treat kind of thing. And none of that worked. They wouldn't play, they got very frustrated, they wouldn't do anything. So competition didn't increase their cooperation. They would cooperate under peaceful conditions. And another one that we did, I won't get it out. I brought this apparatus if you want to see it later, but if you pull one string, one spoon comes out to you and you get a treat. If you pull the red string, 2 spoons come out, one on either side, and your friend can also get a treat, your roommate. And so we tried that. If you're very selfish, you might just pull the one that gives you a spoon. If you're very selfish and you don't get it, you'll pull them both equivalently, right? Because you're still getting a treat. Who cares what happens? We also ran an altruism condition where if you pulled that red string, both spoons would come out and there's only a Cheerio for your friend and none for you. And what we found is they're very selfish. They like to eat themselves and pull the one that has one spoon, but after 3 or 4, they never made it equal, but after 3 or 4 tries, they would go and pull the other one and give both treats. And when it was the altruism condition, they were very selfish, and every once in a while, more rarely, they would pull the other one and the other monkey would get a treat and they wouldn't get one. Okay, I have to show you the funny bits. So the other thing that happens in the lab, I cook dinner for them, I make baked goods for them. You all have heard about my baked goods, I'm sure. And then sometimes fun things would happen. This was a newsletter. I don't know where Janice is right now. But Janice and Kara made this, and has very salacious titles in it, yes. The summer board called it, some of this is true, the summer board called it, actually did happen. We tried mini marshmallows and they barked at us all day. So that was fun. Another thing that turned fun, but wasn't fun at first, was the smoke fire rumor mill that happened a couple of years ago. Somebody put on a different floor of Healing's Hall, somebody put a piece of plastic on an autoclave and it melted and set off the smoke alarm. That was all that happened. There was no fire damage anywhere in the building, and somebody thought they were making a joke on Yik Yak about dead monkeys. And that just was disgusting. Very few people asked me if it was true, which was kind of shocking. And I was sort of just waiting, and if I was asked, I said, no, the monkeys are fine. I don't know what you're talking about. So a couple other guys from the clap, I don't know if the clap still exists, does it? Good. I haven't seen it lately. You're hiding it from me. It's a satirical literary magazine written by students, and one of the students had taken learning from me, and he came up and he said, hey, this whole rumor thing is so ridiculous, right? And I said, yeah. And he said, could we just make fun of it for an entire issue of the clap? Just totally make fun of it. I said, please, yes, nothing would make me happier. And so you can see the poor Photoshop version of the monkey being carried out by a fireman. No more monkeying around. And they had stories. So, yeah, the rumors are true. Every monkey that was planning on living a long and fulfilling life in the basement of Anderson is now dead because of the fire. Because if they died of the fire, it's written really poorly on purpose. First of all, there were too many flames. Second, there were not enough fire extinguishers and the monkeys could not figure out how we could even work them anyway, right? And then it gets into conspiracy theory. It gets better. But if you're asking me, the dirty little secret is that Julie Neiworth doesn't want you to know is that those geriatric little monkeys aren't as real as you may think. That's right. $1.2 million raised for research, which I did. More like $1.2 million raised for, right? Why do you think no one has access to the monkey brain? Incubator fire, right as psychology faculty started to get suspicious, how convenient. And to make matters worse, a different page had menu items for the Schultz Cafe. And it was there was another screen that said carrots. That was your choice. So what did we learn? What do we share with monkeys? Categorizing animals, processing faces, using Gestalt principles, global-local preference, rule switching with cards, visual search, and working memory issues with aging. It's a pretty long list, right? How about socially? I'll show you a video of mirror-directed self-recognition in a second. But they seem to do a lot in front of the mirror that would indicate that. Visual co-orienting, dislike of social inequity, theory of mind, and sharing and cooperation. So there's a lot, right? What makes us unique then? Tool use? Everybody up there is using a tool. An otter, a crow, a chimpanzee, monkeys, come on, right? That's not unique to us. Now, we may be more sophisticated in our tool use, but everyone's got the idea to borrow something to dig out a worm or an ant or something. It's not unique to us. About language or communication, there are lots of, I don't have time to tell you now, but there are lots of people who've studied for 20, 30 years of going in the field. There's one guy in Japan, Suzuki, who's been watching these birds that are like finches, are called Japanese tits, for 20 years, living out in the woods. And he has learned what their calls mean, and they have 2 call and 3 call utterances. And they don't understand them if you switch the order. So when I say alert, snake, if you say snake, alert, they're like, if you say alert snake, they duck down inside their house, they don't leave it. If you say hawk, alert hawk, they'll disperse inside the trees. If you say alert cat, they fly. Okay, so they have different behaviors that they'll show as a response to that. And if you switch the order, that will be syntax, no, right? They also use it to be deceptive. If there's a human there and doing something, the mom will say snake if the human is just dealing with things on the outside. So they just duck down, but they stay inside the house. There's no snake. She's using that to make them do that behavior, right? And so she understands that she can do that. What we do have unique abilities, obviously. One thing that we find in humans that we don't find in other species has to do with how long we can think forward. So we plan a lot of things way ahead of our time. We have a sense of our own life and the end of it through that, and that affects our work. We share knowledge. So we're the only species that has written language, right? A lot of animals talk, have communication skills, but we decided to write it down. Why? Because we want to pass it to others so they can profit from what we know. And we know there's a future and somebody may need this. It might be useful to them, right? So a lot of our accomplishments come from these parts, just sort of extending. We're mad problem solvers, yeah? And we do a lot of social comparison. And that, you have a sense of self, you worry about your sense of yourself and how you're perceived by others. It takes a lot of our time to think about that. Winning is a big deal, right? Apparently, that's all I hear about now. We're winning, right? And what does that mean exactly, winning? So if you think about yourself a lot and you worry about how you look to other people and you set value based upon that, which we all do, yes, then we can be fairly short-sighted about what winning means. Winning might mean making money. Winning might be just being liked by others. We might be compromising a lot of things by the way we apply that. So I think we can do better. We also get designer pets, right, or exotic pets to be cool. And there's a big illegal pet trade around that. That's where a lot of monkeys come from. People think, oh, I want a monkey. I don't want a cat or a dog. I want a monkey. Or I want a wolf hybrid, wolf dog. Or I want a serval cat, okay? And you're mixing a very wild species that hasn't been domesticated. We spent a couple hundred years selectively breeding for the right traits to have an animal live with you. And so you pick a wild one, they're still wild. A monkey is very cute when it's a baby, it's gonna bite you. It's going to bite you, okay, no question about it. It's gonna tear up your house and poop everywhere, right? So everyone decides that, monkeys are cute, that would be cool if I have a monkey. They get rid of them in a year or two when they're big and they're doing all those things, right? So we kind of, and you know, if we have to impress others, we might invade other spaces, we build bigger houses, we create a lot of trash. We're kind of trashing the place, right? With our own interests and our short-term thinking, all about that kind of social comparison. So what do we do about it? So we all have an impact on the world. We can choose what kind of impact we make. And so I've been trying to spread information about monkeys, about primates, to try to improve their situation. Most primates are endangered species now because their environment has been encroached upon primarily. Sometimes it's climate change, sometimes it's a natural disaster, but mostly it's us. And so I think if people know more about animals, or they're watching them a lot, and they learn more about them, they'll appreciate them more, they'll become more attached to them, and they might try harder to protect biodiversity and protect animals. So a couple of years ago, I started working with alumni sanctuary, which houses illegal pet trade monkeys and other species. They had marmosets. I don't like to throw things away, so I gave them all of my stuff after the last tamarin died, a lot of the toys and food and stuff, and made a relationship with them. My Higa runs Alveus, and she started calling me and say, hey, could you watch the monkeys with the viewers and comment and answer their questions? And I said, sure, I'll do that. And it's great. I get like 2,000 people watching every time I do a program. I've been doing it for 2 years every month. And they're very attached to the marmosets. And then they wanted to redo the marmoset enclosure, so I said, sure, I know a lot about monkeys. So I'm looking for my cursor. There it is. So I'm just going to show you a little bit of that, if this will work.
November 3rd, 2025, new marmoset enclosure. So we were able to upgrade the marmoset enclosure.
Look at how
It was
pretty it is.
beautiful. We made it more naturalistic. They have way more perching, way more stuff to do in there. There's paint that was put in there. It looks so good. The marmots are just thriving. And it took a lot of work, and our staff did an
And that's
incredible
me.
job building it. Dr. Julie came out, and she's a primatologist, and she's helped us with all things marmoset since she found us online, and she flew out to help us with that enclosure, and we're super lucky. And she's really awesome, and she's a great friend of Alveus. So.
Okay, that's good. I also, sorry. No. I also provide enrichment for a lot of their animals. You can watch a lot of animals. They're 24/7 cameras on, so you can go to them anytime you want. It's a Twitch stream, and I do my stuff live Twitch stream. That video was watched by 45,000 people. Can you believe that? So there's a lot of people who are interested in animals, and I think with more education around them, we can do something. So I put mirrors in all of these places to check these out. I just clicked one. This is, that was the tortoise. There's a tortoise that used to be someone's pet, and it's going to be enormous. She's going to weigh 100 pounds one day. She's not even full grown yet. There's wolves up in the top corner that they have a giant mirror. It's great enrichment, and we get to see what they do. Where else am I? This is an emu. Do you see this emu here? And there's a mirror right there. And here are the marmosets. So they're very much like the tamarins. It's Momo and Appa, two different species of marmosets who live together. They were pets for I don't know how long, maybe a year. And these are the tamarins from Carleton. This was our mirror study. And we would code all of this stuff. So they're manipulating the mirror. You'll see them do contingency testing pretty soon, which is when they move back and forth. They watch to see if the image moves with them, so they're trying to figure it out. Like that, yeah. And then you'll see there's another part at the end, yeah. So that's Dante. And if you can surmise what he's doing, he's using the mirror to look at his penis. I always try to work a guy looking at his penis to make him talk. So this happens. Okay. Oh, shoot. Stop. There. Okay. The other thing I do is help out with a variety of sanctuaries. This is a crew from Carlton down here, and we shipped all of the cages after we cleaned them up to Oregon Primate Rescue. They're about half illegal pet monkeys that need a home, need a better environment, and half retired research monkeys. And we do a lot for them in terms of enriching their lives. This is something else I've been working on, which is Oregon Health Science University is associated with National Primate Research Center, Oregon National Primate Research Center. And we've been considering for about 5 years now, well, they were going to close part of their monkey stuff. And I suggested they do a sanctuary. And it's very expensive to pay to keep monkeys that are no longer in research because there's nothing you're getting out of them as a researcher. But they're going to live 40 years, rhesus monkeys. And if they're fine after the research, it's great to provide sanctuary living for them. They can't be returned to the wild. None of these animals I've shown you could be returned to the wild. So what do? What we try to provide is a really enriching life for them and something as close to the wild as we could get so they can live in group situations. They can have puzzles and problems to think about because they're not foraging, things like that. So I know a lot of these monkeys, and I'll just show you this one before. I'm almost done, I promise. So these are rhesus monkeys that they can't be housed socially yet. Some of them were isolated before and they don't have the right skill set to do that, but I'm trying to get them to play with things. So I found walls that rhesus monkeys cannot bite through. Or this jet. These are their favorite toys, Polly tells me. Polly Schultz is the CEO of this. So I think, if you think about yourself and what you could be doing, there's lots of things to improve this world we live in that you could do that are easy, what you buy, and in terms of meats and things, pasture-raised chickens, it should have a certified humane stamp on it if it's beef or something like that. We can try not to generate so much trash, right? What we should be trying to do is save the planet, and protect the biodiversity, allow the animals that are still out there to have a healthy environment. And I think of this as sort of a Jenga puzzle, so you can grab your stick and tip the whole thing over, but you have your stick, that's the short term. That's not the point of the game. The game is to keep the tower up. So we need to try to keep the tower up. And with animals that can't go back, we need to give them a full life until they're ready to go. And that's it. Food outside, and there's going to be a movie that shows monkeys from the wild. Does anyone have any questions? We have some mics that are on. Yes.
This is particularly related to research, but I'm wondering if at any point of the last few decades, if you had infinite resources, this is a hypothetical, and you could have a second lab, what would the second animal be?
Oh, a new animal?
That can be anything.
I mean, I'll tell you, I really love having tamarins. If I had infinite money, they would have had, an outdoor enclosure for a nice time. So what we try to do when we go into sanctuary mode, when they're retired, is make sure that they have a larger cage than is necessary by any standard, and an outdoor area that they could go to as well. So if I had research analysts, I would like to provide them more of that kind of thing. Yeah, natural light, it helps a lot. Yeah.
I'm just curious about your current research. You mentioned behavior coding. Can you say more about that?
Oh, so when you watch monkeys or any animals in the field, you kind of code their behavior to try to figure out what's going on, like how often do they do something over a shorter period of time. And you can introduce things in their environment. Sometimes you could put a speaker in and play different monkey calls, for example, from their own troop, from a renegade troop. What do they do in reaction to that? So you could actually do experiments in the field that way, but you usually have to code the behavior. You're watching natural behavior, so it's, if a monkey does something very peculiar, but it's only once in a month, it's not that significant, but if they do it a lot, it means it's a more natural behavior. If they do it in response to something that you're presenting, and they do it a lot more to that stimulus than when you're not playing it, or if they differentiate between two different calls or something like that, then you can learn things that way. So when you go to a zoo or something like that, and you want to say a lot of times you can't do a whole lot. Sometimes they'll let us do things, but a lot of it is behavioral coding. So you watch relationships across groups, you watch how they interact. We can usually give snacks or play calls. They'll let us do that. Anything else? Oh, is there somebody? Oh, Chris. Oh, sorry, I forgot. We're doing the chat. Yes.
So Deborah Rupert asks if you could do one last experiment, what would it be?
With the tamarins
With any?
or with anything? I am continuing to do work. So you can see that I put mirrors in for all of those different species of animals. I do a lot of puzzle feeders and problem-solving tasks with them. I'm really looking forward to helping out. These sanctuaries allow us to do that because it's enriching for them. So we can introduce new toys and games and collect data. That's fine to do. And there's so many more species of monkeys in these areas. It's going to take a long time to turn, if we do turn Oregon Primate Research Center into a large part of it into a sanctuary. The board voted in February unanimously to do this. So I think they're pretty serious about it. The date is 2029, and there's 5,000 monkeys there. So it's a lot. So I'm just helping, because I don't want to get too involved. That is too much. But I will be doing things like that for a long time. I'm also writing a book about this stuff, so another way to spread the word. Yeah? Okay, well, thank you so much for coming.